Hello students, here is a question from photoelectric effect. To calculate the work function which is denoted as phi here, it could be the W naught or E naught as well. Okay, notation will different but concept remains same. It is work function to be calculated. What you are provided with wavelength which is 4000 angstrom units and velocity of the photoelectrons. Okay, now let us apply to solve this problem the Einstein formula for photoelectric effect, which states that, or which can be written as kinetic energy, which is equal to what? Energy minus the work function which is denoted as phi here. Okay, now what is asked there to calculate? What is phi value? So let us write in terms of that. So phi is equal to E minus the kinetic energy. Do you agree? Yes, of course, right? So what I will do is I will write kinetic energy as half mv square in the next step. So phi is equal to hc by lambda. Why I have to write hc by lambda? Because wavelength is given, not the frequency. Okay, what is kinetic energy? Sometimes kinetic energy value will be given directly, but here it is told velocity. So what should I do? I have to apply that formula mv square. Is that okay? Now that is equal to, you substitute the respective values, constants. Okay, 6.626 into 10 to the power minus 34 into c 3 into 10 to the power 8, isn't it? Divided by, am I right? Lambda, which is 4000. Am I right? 4000 angstrom units, so 10 to the power minus 10 minus half into, what is m? 9.1 into 10 to the power minus 31 kg. What is velocity? 6 into 10 to the power 5, the whole square. That's all. Now simplification. So if you simplify this, 10 to the power 16, and you cancel or approximate value you calculate, and you will get it as 4.96 into 10 to the power minus 19. Energy, of course, in joules. Okay, minus the simplification of this 36 into, you write 10 to the power 10, and further again simplified, the value will be 1.62 into 10 to the power minus 19. So subtract this. 4.96 minus 1.62 is 3.36 into 10 to the power minus 19 joules. But in the options, if you see, the energy unit is in electron volt. So why not you convert this into electron volt? Of course, you know the conversion factor. Yes, what is the conversion factor? 1 electron volt equal to 1.602 into 10 to the power minus 19. So divide this answer by 1.602 into 10 to the power minus 19. So it cancels 10 to the powers. So 3.36 divided by 1.602, which is nothing but 2.1 electron volt. So you know now which is the right option. Alright. So option B is the answer for this question. Okay, option B. That's all. Hello dear students, it's a very interesting question, okay, related to again photoelectric effect. Now what is asked? The four graphs are given which I have drawn here, okay. Now which of the following graph is not the right representation of the two variables given? Okay, the sentences are different, our sentence is different there in the question, but that is what the meaning, okay, of this particular question. Which of the following graph is incorrect? Okay, so or does not represent actual variations, the question. Now let us see one by one. The first one, kinetic energy against the energy of the light. The graph is like this. What does it indicate? It has got some intercept. If it started from the origin 0, right? So you wouldn't have this graph like this, it would have been started from here. So let us see whether it is true or not. So what you have to write? Kinetic energy and energy expression. What is that? Einstein formula, kinetic energy is equal to what? E minus E naught. Am I right? So it is Y is equal to mx plus C form. Do you agree? Mx plus C form. It is there. Now I'll write this as a C here. So it's minus C, which is nothing but E naught. Am I right? So if you extrapolate this, you will get E naught value. So therefore this is the correct representation. Y equal to mx, slope is equal to 1. Done. What about the second one? Kinetic energy and intensity. We studied in observation of photoelectric effect that kinetic energy is depending on the frequency of the light used. It is not depending on the intensity. However, number of ejected electrons depends on what? Intensity or brightness of the light. So therefore, it is a constant throughout. It is C. As intensity increases, kinetic energy is not going to change. So this is also the right representation. What about the third one? Number of electrons is depending on the frequency. In what way? Initially it increases, then it remains constant. This is also true. Am I right? So number of electrons is depending on the frequency. What about the next? Of course, after some value, frequency. So this is a threshold frequency we are talking about, right? The metal should have a certain frequency, or even the incident light should have a certain frequency which should be greater than nu naught. Therefore, this much gap is there, then it increasing. So obviously this is also true. What about the fourth one? Of course, this is the right answer, or I mean incorrect representation. Why? Kinetic energy and frequency. You write the expression related or relating these two. What is that? Kinetic energy is equal to, here I have written E minus E naught. Let me put that as H nu minus H nu naught. Can I? Yes, of course. E is equal to H nu, isn't it? So this is also of the form Y equal to mx plus C. So your intercept should be minus H nu naught. Do you agree? So here intercept is 0, it is saying the graph. So actual graph would have been like this. Am I right? So it should have been like this. So here it could be minus H nu naught, which is not given. So this is the incorrect representation. So the right option for that is option D for the given question. That's it. Dear students, here is a question from the energy expression. Of course, for hydrogen or hydrogen-like uni-electron system. Okay, so what is asked in this? Ground state energy expression or energy value for hydrogen atom is given as minus 13.6 electron volts. What is asked? The energy of an electron in the third excited state, but not hydrogen, but for it is helium ion, He plus. So how to calculate this? In order to calculate this energy value, we have to consider the energy expression for hydrogen-like uni-electron system. What is the energy expression, dear students? It is En is equal to minus 13.6 divided by N square into Z square electron volt. Is that okay? So now where N is a, of course, orbit number or the principal quantum number, whatever we say, or integer it could be. So now it is for helium. Now it is required for us to calculate or find out or to know what is the N value. Okay. Now for helium it is told second excited state. For second excited state. Can you tell me what is the N value? See, N equal to 1, just for your knowledge I am writing here. N equal to 1 is a ground state, N equal to 2 is a first excited state, N equal to 3 is a second excited state. So I can write for second excited state N is equal to 3. Now it's almost done, isn't it? E3 is equal to, I can write it as E3, which is equal to what? You tell me. Minus 13.6 divided by, it is N, which is 3 square into, what is the Z value for helium? It is 2, right? So for helium, you can take down here, for helium plus, right, Z is equal to 2, atomic number is 2, so it will be 2 square. Now this is very simple, minus 13.6 into 4 divided by 9, 13 into 4, 13.6 of course into 4 is 54, 54 by 9 is how much? Yes, 6. So your right answer is minus 6.04 electron volt, which is option C. Okay, so that's all.